Welcome, everyone. Thanks for joining me in this session about serverless, and in particular, stateful serverless. A more descriptive title would probably have been Towards Stateful Serverless, but once I figured that out, it was too late to change the abstract. Anyway, my name is Jonas Bonér. I'm the CTO and co-founder of Lightbend. It's a company behind Scala programming language you might have heard of, Akka, Play Web Framework, and some other tools. And I'll start this discussion by trying to frame it to explain to you, sort of the type of the type of applications that I think really needs to really leverage stateful design and stateful thinking. So we can sort of frame this discussion to the type of systems that it's most applicable to. So starting with some industry trends, I mean, the last 10, 15 years have radically changed for us as developers. It's a drastically new world. We started from, it was not that long time ago that we developed for single core machines running on single core developers, single core processors running on single machines, with where latency was within seconds was fine, and we had to tackle sort of moderate amounts of data. But today it's a radically different world. I mean, distributed systems is here to stay. When you embark on microservices, you can't avoid it. You're entering this world of distributed systems where there's a lot of uncertainty between the nodes, and messages can fail and be reordered and all of these things. And we have multi-core, we have cloud computing, with IoT and mobile. We have this whole sort of category of streaming apps and big data apps and AI and all of those things. So it's radically different, and we're moving towards a lot of apps need to tackle this sort of never-ending stream of data in a real-time fashion. So we have this whole category of apps having to tackle real-time data-centric streaming type of applications, so grab data while it flies by and be able to sort of present the user with intelligent answers almost immediately. And finally, we're moving towards a world where we have sort of automated operations. I tend to call them ops-less. Some people call it different things, but this is the world of serverless. The serverless have really shown us the path of what's possible when it comes to these things. I think the monolith and the three-tier architecture has really served us well, but its death is really overdue, I believe. The classic three-tier architecture usually has a lot of problems. It usually has like too high latency, all these round trips down to the database, with transactions and locks, sort of stop the world type of locks makes it really, really hard to build really high throughput, really low latency type of systems. And that might be fine sometimes, but for a lot of these new type of use cases, it's actually often too slow. You have too high contention, too much coupling between components. It's really hard to build truly available systems, because you can easily get into this problem with cascading failures. One service taking down the next when they are too tightly coupled with synchronous coupling between them and between services and the database. And I think that we need sort of new tools and new ways of thinking, new practices in order to deal with these things. And stateful is really at the heart of all of this, because data locality means that sort of putting data close to its processing context means that we can actually serve users with intelligent answers faster and faster, or as fast as needed. But there's a lot of problems that comes with that. I mean, data now needs to be replicated between nodes for availability rather than shoving it down to the database all the time. And you need to fully embrace asynchronous processing as well as both asynchronous I/O and asynchronous communication. And Reactive has really started to become sort of framework or that a lot of people use, or frameworks use in order to conceptualize, what's needed, the design patterns and the practices that's needed to tackle these new challenges. The Reactive Manifesto was created about 5 years ago to try to frame this discussion, so to speak. And we move into a world where data is king. I mean, data has been important for a long time. Companies have been storing down vast amounts of data down into data lakes. But a lot of companies really don't know what to do with it. And some have sort of embarked on over the years to do sort of batch processing overnight, but that proves to be too slow nowadays. I mean, speed has really become the competitive advantage. How fast can you deliver sort of intelligence or knowledge about the data that you receive, intelligent answers to your users? And we're starting to see sort of this convergence between the microservices or the application development world that often needs to be very data-centric and very data-focused, as well as the big data that also need to sort of reply intelligently in shorter and shorter time space. So we see this convergence into what I call fast data applications. So this is sort of the new type of apps that I'm sort of discussing that we need to tackle and can fall short with the current incarnation of serverless, so to speak. I took this quote from a positioning paper by Berkeley that came out a couple of months ago, where they say that, and I quote, "We predict that serverless computing will grow to dominate the future of cloud computing." I really believe that this is true, even though the title might have of my talk might have, I was less enthusiastic when I wrote the abstract, perhaps. I really believe that serverless is great because it gives us sort of this unified solution to both one way to cutting operational costs as well as development costs. Being sort of cost efficient, pay as you go, scale down to zero, as well as scale up as sort of the load varies, which is very often will do when you put them online. When the users are unpredictable, slash dotted used to be a term when I started, but it's really developing. But it's really becoming more and more important today. Black Friday or whatever. Both unpredictable load as well as predictable load that you can plan for. So, and automation is one thing that really has made sort of really great when it comes to serverless. I mean, automation of scale, automation of failure handling, automation of recovery, and in general, a great developer experience. To actually moving to the cloud, because that's hard. And this lift and shift model where you bring along a lot of your historic knowledge, patterns, and even tools and products, really that doesn't work. And serverless, shows the way here, but it can actually be a simpler world moving to the cloud, not a more complex one, by sort of doing a lot of the heavy lifting. And finally, reduce time, complexity, and risk. But I think it's very important, a lot of people, they confuse serverless with function as a service. They overlap absolutely. I think function as a service is a great first step, towards this nirvana, sort of this utopia of serverless, of opsless. But I think it's just the first step, and I would be really sad if only function as a service had all the fun, so to speak. I think serverless really shows a glimpse of the future of cloud computing, what's possible. And we see a lot of initiatives like the Knative project, for example, trying to expand on sort of the notion of a serverless means and put that into sort of a context that is broader than function as a service, which is great. I'm not really here to pick about function as a service per se, but I think I just try to explain what I think is good and bad about it anyway, so we know where I'm starting from here. So, as I said, I think it's really good that it's sort of paved the way for serverless, shown what's possible, but it's just one incarnation of the serverless idea, I believe, the first step. But it sort of showed us that it's possible to scale on demand from 0 to tens of thousands of requests, in a really cost-efficient manner. The economics of scale can really play at your advantage here. It really simplifies delivery of scalable and available applications, makes it actually possible to move to the cloud and reduce risk instead of increasing risk. So it encourages good distributed system design. Forces you to focus on events, an event-driven model, events first design. I don't know if you heard of events first DDD, but it's something that's proven to work very, very well. It gives you, by default, loose coupling that opens up for scale and availability. It works great as sort of an integration layer between various ephemeral or durable data sources. It's great for a stateless type of work where you have processing-centric use cases, okay? And finally, it's great as sort of the general backbone, moving data from A to B, doing transformations along the way. So some use cases that sort of fits in this. I mean, in general, I think is generally use cases where throughput is key rather than low latency. This is really important, and the large category of use cases fit this very well. And requests can be completed in a reasonably short time window, okay? Applications of this, or use cases of this, is like low traffic applications like IT backend systems, for example, stateless web applications where you can serve static content from S3, for example, or embarrassingly parallel processing tasks where there's really no coupling between your tasks, but they keep, meaning no contention. There's really no need to coordinate, but you can just scale it out in what is called, in academia, with embarrassingly parallel sort of type of patterns. Examples of this like resizing images, object recognition, log analysis, etc. It's great for orchestrating functions like integration, coordinating of a set of third-party services, and also some composing chains of functions, sort of that where you sort of compose them based on data dependencies, sort of driven through the need of the data. Also job scheduling, of course, like cron type of jobs and things like that. But then what's bad with function as a service then? I think it's really, really hard to build general purpose applications. Most of the use cases we've seen here, are usually part of a larger application. So this means that for that part of your app, it's a great fit for serverless. But what about, building general applications? Ideally, I'd like to see everything move to the serverless idea. Of you don't need to have to manage service. You sort of having knobs to turn, instead of all the hassles of distributed systems and operations of the cloud. So some of the problems in more detail is that I think it retains a lot of limitations of the three-tier architecture that I started talking about. One of the problems is that's also the advantage, I have to say. But in general purpose applications, one of the problems is that functions are stateless, ephemeral, and short-lived. I'll get back to that. Another is that there's no direct addressability. You always need to communicate over some sort of storage medium, which is great, for durability and things like that. But it is actually possible to make it as reliable with point-to-point. And without having to pay the latency of always going down, communicating over some message broker, As I said, different use cases have different requirements, but always having to do that is quite bad for general purpose distributed systems. Another thing is that there's really no notion of co-location, where I can physically say I would like to co-locate processing and state over there. So it doesn't need to go and fetch it every single time. Locality reference is something that we value a lot, when we're working with more low-level type of programming, and it's actually the cost is even greater with the higher up the ladder we climb. We also have limited options for managing and coordinating distributed state. State management is the hardest thing in distributed systems, right? I would like to have wider range of options for managing these things, supporting more use cases. Limited options of modeling consistency guarantees. It's not a one-size-fits-all. Everything is strongly consistent, or everything is eventually consistent, But I'd like to, be able to use whatever is needed for the actual problem. Strong consistency should not be the default, in my opinion, in distributed systems, because there's too much drawbacks, even though it makes the world easier for us programmers when we code. It makes the system more brittle, less available, and things like that. On the other hand, always having eventual consistency is not good either, because there are certain type of use cases that require strong consistency. So more consistency a la carte would be nice, okay? Also limited options for managing durable state in general, okay? So what I want, if I should try to capture it very briefly, is I like the serverless experience, but for general purpose applications. I'd like to put all our clients at Lightbend that's using Akka, FaaS data on serverless eventually. That's not an option today. You know, I'd like to have some sort of abstraction for stateful functions, which I will dive into more what I mean. Complementing stateless, you know, not replacing them. I would like to have more tools in the toolbox, essentially, supporting a broader range of use cases. But I wanted to do that, you know, with not throwing out the baby with the bathwater. You know, a lot of the reason why people gravitate towards serverless is for the cost efficiencies, right? So we still need to maintain the cost efficiencies of function as a service, of serverless. But perhaps having ways to dial them in, you know. All guarantees that you add on top has costs, you know. So having a way to dial in that as a user, the trade-offs between consistency and availability, etc., would be nice. Okay, so a list of some of the use cases that I would like to have support for that I find hard, not impossible. You know, serverless, most models are Turing complete, so you can essentially do everything, if you follow me. But being able to support these use cases in a really available fashion. Our use cases like, for example, training and serving of machine learning models, and essentially any dynamic sort of in-memory model that's constantly being updated and needs to be served. Okay, real-time distributed stream processing, you know, concrete problems like prediction, recommendation engines, anomaly detection, fraud detection, and these type of things. Modeling user session or shopping carts and you know, caching. Essentially, any sort of in-memory sort of construct that sort of outlives you know, requests. That has its own, so you can model your own sort of life cycle for. So it's available until you explicitly destroy it. And you know, things like distributed resilient transactional workflows. Like in event-driven programming, we talk a lot about the Saga pattern, which is a really nice way of modeling, you know, distributed workflows in a reliable fashion without having to go back to XA transactions, you know, which will doom us. Modeling shared collaborative workspaces, you know, things like document editing, Blackboard type of systems, and also being able to, in a good way, you know, sort of modeling classic distributed computing patterns like leader election, etc., would be nice as well. So some of the technical requirements in order to get here, I think, is that first we need to have some sort of abstraction, some sort of possibility to create stateful, long-lived, addressable virtual components or functions, you know. And what do I mean by that? Yeah, first, stateful, I mean in-memory, durable, resilient state. Not necessarily stay down there, you know, or not stay down there, but stay up here, but that's still backed by durable state. I explain more how. Long-lived, I mean that it's actually outlived specific individual requests. It's more tied to a specific session that's available until explicitly destroyed. Okay? Addressable means that it should be referenced through a stable address that's always available, even though I send the address around, even though, you know, the actual instance of the function might be moved around. You know, when nodes join, it needs to be reallocated across all nodes, for example, and things like that. And virtual is what I mean by location. With virtual, I mean location transparency. That the user of the service shouldn't really need to know where it is. Some of these problems Kubernetes and sort of things like Knative solves for us, right? Others not. I also would like to have sort of support for a wide range of communications and coordination patterns, and also things, as I talked before, options for managing consistency. You know, managing distributed state at scale, while not giving up the guarantees that we have set once set, you know. Also things like intelligent and adapted placing of functions, being able to do that in intelligent fashion, I mean where the state currently is, and vice versa. So you can have co-location, physical co-location of state and processing for really, really low latency. Not everyone needs that, but some really do, you know. Oops.
The keynote doors are now open. Please make your way to Hall 6, across the hallway for 4:45 start.
Okay. Is that my sign? Okay. So I also want ways of managing end-to-end correctness, not just thinking about each individual function, but actually thinking about, the larger scope, and being able to reason about the guarantees that the whole workflow has as a whole. I think is extremely important as complexity grows. And of course, having predictable performance, latency, and throughput. So, one of the great things with function as a service is that it gives us a very nice way of abstracting over communication. You have sort of, in a really abstract way, message coming in and message going out. And the framework or the runtime manages all the nitty-gritty details of making this happen. That's great, and it's a perfect model for stateless type of work. But sometimes you do have to manage state, But the problem is that if your functions then talk directly to the database, you're essentially moving all the operational concerns, all the things that we wanted to abstract away into the user function himself. And this makes it very hard for the framework to do any useful work, because it really doesn't know anything about how you're actually using the database. It can't really do auto-scaling. For example, if a function responds slowly, is it because the function is overloaded, or is it because the database is overloaded? The framework really can't know. Okay? So I really don't believe that this is true serverless. In general, I think sort of unconstrained database access makes it really, really hard to automate operations. And in a CRUD, create, read, update, delete, that we use with SQL databases, is really a problem here, because it makes it really hard to understand the intention of each request. Is it a read or is it a write? Can it be cached? Can the consistency requirements be relaxed or not? Etc. Right? If we understand these things, then we can make better decisions. And if a framework and runtime understands it can make better decisions. Okay? For example, write operations are fast, read operations are slow. We need to add more memory to the database. If I'm constantly reading only immutable values, let's add caching, for example. Writes might be serializable, or must be serializable. We can add sharding and sort of making sure that we relay every single request to that entity on that pod every single time, for example. And as Rune Bjarnason said, is a friend of mine from the Scala community, said that constraints liberate, liberties constrain. And we all know that constraints can really be liberating. Endless options can kill productivity and kill urgency. So I think that sort of limiting the options for state and database management can actually be a good thing. And we can do that by trying to sort of abstract over state instead. Okay? We already have an abstraction for message in and message out. Okay? What if we have an abstraction, a way of abstracting for state in and state out instead? And having sort of the framework manage all the nitty-gritty details of this for us. Okay? CRUD really doesn't work that well in this model, because we can't pass the whole database in and out every single time. So the question is, if we can't use CRUD, then what can we use? In my experience, two really good models for modeling the distributed scale, are event sourcing and CRDTs. How many have heard about event sourcing and knows what it is? Okay, almost everyone, that's great. What about CRDTs? They stand for conflict-free replicated data type. Less so, okay. I'll try to just explain briefly anyway for those that don't know what it is, so you have at least some context, okay. And let's say we have an event-sourced function now. What will that look like? We have one user sending a command, because with event sourcing, you tend to have commands and events. Commands are framed in the imperative, or phrased in the imperative. For example, create order. So a create order command is sent down to this function. It's sort of ended up in his mailbox or wherever, and it triggers some sort of action, creating the order. Out of that order, when we have done that, then we create an event, which is like a fact, the fact that we already have created an order. So events are usually named order created, the fact that the order has already been created. And in event sourcing, what we do is that we just store all these state-changing events, events representing a state change, in an event log, durable on disk, in the order they arrive. Okay? we can also, have others subscribe to that event log if other parties are interested in knowing what, the updates or the events created by that function. Okay, this is similar to functions as a service today. But this is the happy path. Then what happens then if things start to fail? Or if you just need to activate and passivate the function. So the sad path, when we now recover from failure, the only thing we need to do is sort of replay the event log in the order the events arrived. There are of course optimizations. Akka persistence is the event framework or the event sourcing framework we have in Akka. Allows you to do like periodic snapshotting, in which on replay you search for the first snapshot, instantiate that, and replay the event log from there. But the beauty of this is that you have one single source of truth for all history that ever happened in the system. We never do destructive updates, sort of compare, sort of update in place like we do with SQL databases. But everything that ever happened in the system is there. In the order, it happened. And this, even better, this allows us to work with durable in a memory state, without having to do any object-oriented mapping. We never need to go down and fetch the state every single time we want to use it. It's there, it's in memory, but it's still backed by a durable event log. If things fail, we just rehydrate it, okay? It also allows others to subscribe to state changes. It has really good mechanical sympathy. What that means is it is in line with modern hardware. You can have single writer just writing down very, very fast. Works perfect with SSDs, down into the event log. And you can replay this log, not just when things fail. You can do it for audit reasons, debugging reasons, replication, to have multiple hot replicas and things like that. So the question is then, how does event sourcing fit into this state model? Yeah, you have state in your event log, or if it's a replay, one by one, the events that sort of arrived up to this point. And state out is essentially the event that you emitted, so as representing the latest state change. Okay, so this is great to use as a model to model, what you normally would use CRUD for your source of truth, your domain model, that type of persistence. Okay. I've also mentioned that CRDTs are also great. They are also a really good way of managing state, but for slightly other type of use case. Okay, so it sort of implements the idea of ACID 2.0. I don't know if you heard about that. It's sort of funky acronym for it stands for. It's really a really nice way of thinking about the state in distributed systems. So A here stands for associative, meaning that grouping doesn't matter. Okay, that's a really good property. C stands for commutative, meaning ordering doesn't matter. It's also a great property in distributed system. And I stands for idempotent, meaning the duplication doesn't matter. You can actually receive the same request more than once. And CRDT stands for conflict-free replicated data types. It's sort of fairly recent research, but we've used it in Akka, and our clients and customers have used it for quite a few years now. It's a term, Reactive, if you remember that database. Sadly that it went away. It was one of the first actually to implement CRDTs in production environments. So CRDTs essentially, as I said, it implements ACID 2.0. It has strong eventual consistency. It's replicated and decentralized, and the really nice property is it has this. It's always converged correctly. So you can have all these these data types flowing around, and eventually they will always converge in a correct fashion. Okay, which makes it extremely available and extremely scalable. Okay, and the data types that are currently sort of discovered by the research community that we have implemented is counter, registers, sets, maps, even graphs. And the nice thing with these, if they are a CRDT, they compose. So you can have a map of counters, for example, or a set of maps of counters or registers or something, and they all adhere to the same type of properties. Okay. So what does that look into our state model here then? Yeah, we will have, instead of the event log in now, we have the deltas in. The deltas, sort of the changes between the different updates of the CRDTs. And out we have the deltas out. So it nicely abstracts over CRDTs as well. And CRDTs are great for doing distributed coordination of state, for example, without ever going to sort of a durable medium. You can do that. We have options for that in Akka, and many implementations do. But if you just have enough nodes, enough replicas that you replicate to, it's available enough, so you never have to really persist it on disk. So it's great for coordination, for snapshot state, for session type of state, shopping cart user sessions, and that type of work. Okay, so this was a long rant, and some hints on how things could be done differently. So what are we doing about it here? I mean, we actually try to do some work around this as well at Lightbend. So currently we're working on a POC. It's all open source. I'll link to it in the end. On top of Knative, on top of Kubernetes, on top of Knative, around gRPC and Akka then. But first then, before I dive in a little bit about how we've done this, how many know what Akka is first? About half. So I'll just explain it very briefly. It's sort of an implementation of the actor model. If you heard about Erlang, I mean, I created Akka some time ago, and I was heavily inspired by Erlang. So, and it has this notion of Akka cluster, that's sort of decentralized self-organizing, very simple to the dynamo model for having these actors sort of self-organizing and making it very, very available and scalable. So it's extremely high throughput. We implemented a ton of different protocols. But the most important thing is that we have really good support for distributed state management. That's what Akka does well. And that's also one of the hardest things you can do in distributed systems. So if you want to find out more, you can go to akka.io. But what we're doing here now is, the vision is, I don't know if you know about Knative, but Knative have Knative serving. So it's that we will have a new component called Knative stateful serving, okay? In addition to Knative serving, to serving stateless workloads. And so you have a bunch of functions then that sort of runs sharded on different Kubernetes pods here, and all communicating then over gRPC, working as a proxy for these functions for the user, okay? The role of stateful serving is that it speaks gRPC with these functions. It routes inbound communication to and from these functions. It communicates with the database on behalf of the functions, abstracting away all that hard things. And it also emits events to Knative events for public consumption, okay? So if we dive into Knative serving then, how does it really look inside then? Yeah, inside there we inject one Akka sidecar instead of the regular Knative sidecar, into the user function. That works, it sort of sits as a proxy on behalf of each one of these functions. And it manages the state and the communication on behalf of these functions. And then the one thing that Akka does really, really well is for example, cluster sharding. So in this case, we have for each function that we call an entity then, has an entity key. And Akka cluster actually, so shards these across all the pods and making sure that we have sticky routing for each one of these functions. So you have really good data locality on each one of these pods for each request coming in. Okay, so Akka cluster, by the way, is sort of a gossip-based, decentralized, masterless, peer-to-peer type of implementation. So Akka here abstracts and manages all the distributed state, even if you use, for example, event logging or CRDTs, or any future type of distributed state type of management, okay? And of course, these functions can be implemented in any type of language. So just to wrap up, I really believe that the serverless is revolutionary. I think it shows a glimpse of what's possible with cloud computing. I think function as a service is a great first step, but I would be devastated it was the only step. I think it shows what's possible, but it's only the first step. We need to take it to make it live up to its promise, so to speak, okay? And I think serverless 2.0 or whatever you want to call it, needs a runtime programming model for general purpose applications. I want to build everything in this new style, right? And we have said we've started working on it with Knative, Akka, and gRPC, and we need your help. It's open source. We need feedback, ideas, or if you're interested in hacking on it, roll up your sleeves and hack on it. We created a little. It's about a month old, but this bit.ly link is to a little demo. If I would have had an hour here, I would have given the demo, but now we recorded it instead. So if you want to find out a little bit more what we're thinking about what the user experience could look like, and the GitHub repo is right there, so you can just check it out and clone it and get started if you're interested in these things, file issues or whatever. Thank you. I don't think there's any time for questions, but I'll wait right outside there if you're interested in chatting about these things. So thanks a lot.